So we talked about ETL versus ELT, and I think everyone's familiar with this. The value of ELT, most of the values are well understood. Why do we do it? Fundamentally, we do ELT because it gives us as close as possible to the raw data. We do schema on read, which means that we impose additional schema and logic as we read it, not as we write it, which means in the future, when we want to do something different, we haven't lost access to that rawest data. Most transforms are irreversible. So if you do a transform before you load it, you can't get the original raw data back, and that closes down future opportunities. Speed of ingestion is important. ELT is far quicker than ETL. You should be able to ingest new sources measured in days, not measured in months. It's lower complexity. We're moving the transformation from a systems which often don't scale inside the data warehouse, which in Snowflake's case is essentially infinitely elastic. When we talk about loading patterns, full load and incremental, of course, both are possible. Full load being, let me grab everything that's there and recreate it over here. Incremental being, let's just move the changes. There's a lot of factors that affect that: size of data, frequency of update, things like that. One of the things we see, this goes back to human time versus machine time and parameter optimization, is people say, oh, I need to do incremental updates on this table. Why? Oh, well, because it's changing every hour. Okay, that's true, but how big's the table? 100,000 rows. Okay, how long is it going to take to do 100,000 rows every hour? 2 seconds. Okay, do we actually need to do incremental on that? The technologies and this power is at the point where actually at 100,000 rows, you may legitimately say, I'm going to do this every hour. Why not? Intuitively, it almost seems wrong to do 100,000 rows when you could do 500. But actually, when you look at it objectively and say, what is the cost of doing this? It's 2 cents a run. Actually, the cost of creating and monitoring that incremental ingestion may well just be, let's just do it every time. The point at which it makes sense to go from full table to incremental is actually a lot higher when you do the calculations than a lot of people think. We've talked about the modern data architecture, so I don't need to go through these. I think these are pretty well understood. So this is important. And actually, the spirit of ELT was one of our 7 pillars. Let's drill down that a little bit further. To say this future-proofing another way is, let's never throw away data we might want later. That seems a fairly not uncontroversial statement, but let's consider the following. Let's consider this very simple employee table. I've got employee ID, name, a job title, and a salary. At some point in time, Joe gets promoted and gets a pay rise. This is called a slowly changing dimension, and it's a very, very well understood concept in databases and data warehousing. The approach that we've got above is a type 1 slowly changing dimension, which basically says every time I ingest it, I just overwrite this data that's there. I just get the new data. Effectively, I lose the old data. But you think about, is that really future-proof? Consider the use case from someone in HR. I'd like to model people's, they ask in 5 years' time, I'd like to model people's promotion over the last 5 years. Well, actually, all you can tell them is this is what people's job titles and salaries are today. When they say, oh, how do I get the last 5 years of data? Well, you can't. That data's gone. So there's a solution to that problem. We create a type 2 slowly changing dimension table, and that has a concept of start time and end time for each record, so you can track records as they change. But the problem is, if you only do this when the HR department asks, you say, great, we can now track this going forward. They say, oh, but what about the last 5 years of data? Oh, sorry, you should have asked for this 5 years ago. We have to put this in place to collect the data for when you want it. So we get future changes, but we can't go back in time, because essentially every day we ingested and overwrote this, we threw away some data, which isn't really in the spirit of ELT. Why do we not create lots of change in dimension tables? The simple answer is it's an economic battle. Historically, they take a lot of effort to create, they take a lot of effort to maintain, and therefore you need a business case before you can create the code. But there's a bit of a catch-22 there, because we're saying, well, we need a business case before we can implement an SCD, but by the time we've got the business case, we need the historic data, and we don't have it because we can't get it until we create an SCD. So there's a bit of a catch-22 here. And the answer, how do we break the catch-22, is simply we have to change the economic. If we can make the effort and the cost to create and update these SCD tables to be trivial, then the barrier to saying, well, I don't know what the HR department are going to need in 5 years' time, but if I do a sensible look through all the tables and say, which of these could they conceivably want to be tracked over time, and I can implement them, and the cost and effort of that is trivial, then 4 out of 5 of those may never be needed. But when the 5th one comes along in 5 years' time and HR say, oh, I need to be able to track this, you can say, not a problem. We implemented this 5 years ago. I've been tracking on a daily basis all of the promotions and changes, and now you've got a rich 5-year data set. So one of the things that we built into our modeling transformation layer is a very, very straightforward way, from a templating perspective, creating an SCD, or what we call a snapshot table. So this is it. To achieve the whole use case I described, it's a select statement with a bit of configuration at the top that says what my unique key is, the strategy is on timestamp, and that's it. I create that. It gets run as part of my pipeline. In fact, we have a specific step often just to update all of my type 2 SCD tables. That's it being executed. So by changing the economics, what a lot of our customers are saying now is, rather than saying, okay, these are the 3 tables that I know I need to create an SCD on, they look and say, these are the 15 tables which I know it makes no sense to create it on, but I'm going to create it on the rest. And I'm just going to do it because it's cheap, it's easy, it's straightforward, it's robust, and I will be collecting the data for the future, even though I'm not sure exactly when or where I'll need it at this point. So that's kind of the spirit of ELT. People just think about it as, yes, I don't transform the data, I keep it in its raw form so I can do different things with it. But actually, when you get into it, an awful lot of the time when you're doing full table ingestion, you are effectively, every single time you do a truncate and load, you are effectively throwing data away. We've moved from sort of slowly changing dimension tables to be an exceptional case to solve certain use cases to being something that we almost expect to set up a standard. There almost has to be a reasonable reason not to create one because the cost is so low and the potential future value of collecting all that data is so high.